Okay, this is a test. We're looking here at a shortened HPLC port and calculating the dead volume here, which is trapped below the ferrule shown in yellow here. So we have the red tubing coming through the center of the port. The nut which compresses the ferrule in yellow here is not shown, but the red section is tubing. The blue section is fluid passing through the tubing. We're going to neglect dispersion due to eddy currents due to this diameter mismatch for the moment. We're only concerned here with these dead volumes on the perimeter of the tubing. These are unswept dead volumes, assuming that the tubing is completely bottomed. But if we look really closely here, we don't have a seal, so it isn't completely bottomed. This is an indeterminate sort of situation, the amount of sample or material that and how it interacts with this volume. But the purpose of this little exercise is to take a look at this diameter, the D port diameter, which we see here, which can vary from, well, the spec is 0.0625, 1/16 of an inch. But we can see that vary quite a bit, and it's not uncommon at all for it to be 0.067, as has been determined by measuring various ports on columns and injector valves and detectors using pin gauges. The diameter of the tube is nominally 0.0625 inches, which is 1/16 of an inch. In my experience, it's been lower than 0.062 for PEEK tubing and higher than 0.062 for stainless steel tubing. PEEK tubing tends around 0.061 and varies by perhaps half a thousandth. Stainless steel tubing can run from 0.062 to 0.0645. This L tube parameter is the length here that the tube protrudes from the bottom of the ferrule, and it determines of course the height of the cylinder. The cylinder we're concerned with here is a hollow cylinder, and the volume of that hollow cylinder is calculated by subtracting the volume of the tubing from the volume of the port, and that 0.28 microliters in this case is the amount of dead volume per port. Now below here we have ports in a minimum system. Minimum system would use a tubing to connect an injector to a column inlet, then another piece of tubing to connect a column inlet to a detector inlet, and of course on each of those pieces of tubing you would have two ports or two fittings with two fittings. So whatever dead volume here, assuming it's the same for each port, which it is not going to be, each port will have a different diameter, the diameter of the port. Each port will have a different length of protrusion, perhaps very slightly, but perhaps significantly. Column, you would think inlet and outlet would be the same. Not necessarily so, but you would think. And in any case, a typical value here, 0.067, produces 1.82 microliters of dead volume in the entire system. It is very worthwhile to note that in a modern UHPLC system, perhaps such as the water's acuity, the detector dead volume is 500 nanoliters. So it's getting close to a third of the, or about over three times the dead volume is accumulated in these unswept ports. Now, how significant they are with respect to the types of flow here and the amount of sample carryover that can be seen is beyond the expertise of this particular commentator, and certainly temperature, situation, viscosity, flow rate dependent. So we'll conclude now by concluding Any questions, please visit www.uhplc.com, and I'd be happy to try to answer any additional questions.